So in problem number 1, we have a player kicking a football. Okay, it's going to go in the air, and there's a few parameters we know. For example, we know the distance here, 82 meters. We know the time in the air is 4.1 seconds. All right, and what we're looking for ultimately is like how fast is the player kicking the ball. So let's go ahead and write down what we know. So remember, we are going to isolate our x direction and our y direction. So we'll throw down our variables. So v initial, v final, acceleration, displacement, and time. And we'll just kind of write these down for each of our 2 dimensions. So the initial velocity is unknown for both. Final velocity is unknown for both as well. The acceleration in the x direction, this is going to be 0. Once it's in the air, there's going to be no air resistance, nothing slowing it down horizontally. Now vertically, we are going to have a negative 9.8 because gravity is the only object acting on it, slows it down on the way up, speeds it up on the way back down. The displacement in the horizontal direction, we can see that's going to be 82 meters. In the vertical direction, since we end up where we started, we're going to say that that is 0. And then the time for both is going to be 4.1 seconds. So remember, the key number of variables you want is 3. And since we have 3 for each of these, then we know we can find the v initial for each of them. So let's go ahead and do that in the x direction. We're going to use this equation, delta d equals VOT plus 1/2 AT squared. All right, and since acceleration is 0, that really simplifies the problem. So this is going to be 82 equals the initial times 4.1. Solve for the initial, and you get 82 over 4.1, which gives us 20 meters per second. Now remember, that's not the total velocity. That's not what we're solving for. That's only the horizontal velocity. We're also going to need to solve for the vertical velocity. So we'll go ahead and set this up the same. And I'm going to use the same equation. So VOT plus 1/2 AT squared. Okay, so our displacement is 0 this time because we end up at the same place that we started at. The initial we're solving for, the time here is 4.1 seconds plus 1/2, negative 9.8, and then we're going to go 4.1 squared. So go ahead and do the algebra on this. When I do it, I get the initial of 20 also. So notice that means we have 20 in the horizontal direction. We have 20 meters per second in the vertical direction. So we're going to solve for the v total here, and we're just going to use the Pythagorean theorem. So that means 20 squared plus 20 squared should equal like the v total squared. Right, so when you do that, I get 28. And then we're also going to solve for the angle. So this angle, now you can see this is an isosceles triangle, so the angle is obviously going to be 45 degrees. But if it wasn't, if you didn't know what it was, then you would just use kind of your tangent function, inverse tangent of the opposite. So that would be like the Vy here over the Vx, and solve for it that way. All right, let's move on to the last part of the problem, letter C. So for letter C, we're looking for the maximum height. So how high did it reach? So for this one, notice all we really care about is the vertical dimension. So we care about the y dimension here. So for example, we already know the v initial in the y direction. We solved that in the last case, that's 20. Okay, and then the key thing here is as it's rising, it's slowing down, and then it temporarily stops Vy, we'll call it at the final here. It temporarily stops at the peak. Okay, now that doesn't mean it stops completely, it just stops rising. And so the vertical velocity is going to be 0. The acceleration is still gravity. And then we are solving for a displacement here. Okay, so we'll be using this equation, Vf squared equals Vo squared plus 2AD. Vf is 0. V initial is 20. Remember, that's just the vertical velocity, 20. And then we'll go negative 9.8 times d. Okay, go ahead and solve for this. So 20 squared gets negative technically divided by 2 divided by negative 9.8. And I get 20.4 meters. Okay. All right, let's move on to question 2.